In this video, we're going to introduce complex numbers. Mostly, we're going to focus on imaginary numbers. So first of all, where do imaginary numbers come from? We're going to start with exponents. So when we know that when we raise a number to the second power or something squared, it means multiply these two numbers twice. So if you think about it, if suppose we raise a positive number to the second power, which means we're going to multiply this number twice. So you're going to get this positive number times that positive number, and by the sign number rules, we know positive times positive, it's gonna give us positive. If we raise a negative number to the second power, that means we're going to multiply this negative number 2 times. And as you can see, negative times negative will also give us a positive. If we raise 0 to the second, we're going to multiply 0 2 times, and that will give us 0. And notice that, look at the answer we got. We either got a positive or we got a 0. So we will never get a negative when you raise something squared, either positive number or negative number. Well, you can look at, say, if I raise positive 3 squared, we're going to get 3 times positive 3, which gives us positive 9. But if we raise a negative 3 squared, we're going to get negative 3 times negative 3, which is still positive 9. So we are not going to get a negative number. The smallest square number is 0. So, and also we talk about the square root. We know square root is reversing square. So if we ask you what's the square root of 9, you're going to get 3. If we only talk about a positive root. And so what if we try to, because square root is asking which number squared is 9. Of course 3 squared is 9, so that's why we get the answer as 3. But what if we want to do can we do a square root of negative number? And that's like asking you what number squared is negative 1, which is, so rewriting this question will be what number squared is equal to negative 1. But we know that it's impossible, because when you square any number, you're not going to get the smallest number you can get is 0. You're never going to get a negative. So it's either 0 or positive. So that it's impossible to get an answer. And so that the number that we usually talk about we are called real numbers. So when you raise a real number, you never get negative 1. So this is something that we have not, all the numbers we know will not work. Say if you put a 1 here, 1 squared is going to give positive 1. You're not going to get negative 1, so it doesn't work. If we put negative 1 here, negative 1 squared is negative 1 times negative 1, which is also positive 1. It doesn't work either. So there's not really an answer for this. So because we are thinking of the numbers we are using is the numbers we know so far. So that tells us this cannot be the numbers we know. It has to be a new number. And what is that number? So we could define this number, square root of negative 1. We're going to use, we call it an imaginary number. So we take the first letter I and use that to denote that this number. So what's square root of negative 1? Most of the simple calculators will not even give you an answer. If you try to do square root of negative 1, they would just give you an error message, because the simple calculators are not programmed to deal with imaginary numbers or complex numbers, because most of the basic calculation in real life will only involve real numbers. But imaginary numbers or complex numbers, they do have a lot of applications in engineering. So let's see. Well, so again, we're only going to introduce, we're not going to talk about a complex number. So what's a complex number? Complex number is you put a real number. Say, for example, you have 3. And plus or minus another real number. Let's say we can even do a fraction, say 1/2, times this imaginary unit, I. So I here, we call it an imaginary unit. So you can use this imaginary unit and multiply it with any real number and the plus or minus another real number. So together that's called a complex number. But we are going to be focused on the imaginary unit here. So let's look at some more examples about imaginary unit. So we know square root of -1 equals I. So that's something we need to remember. We need to memorize it. So that's what's I? I is just a number that we have never seen before. It's called an imaginary number, imaginary unit. And so if we want to do square root of, say, -9, what will we get? So again, whenever you see a negative number under the square root of sign, you immediately will have to introduce the imaginary number. And then after you put the imaginary unit, I, it's going to get rid of that minus sign there. So it's going to turn that into a positive 9. So this process here is how we simplify the square root of a negative number. And so again, to get rid of we know the square root negative number is not going to be real number. It's going to be imaginary or complex. And so first we have to put a imaginary unit I, and then get rid of that minus sign. Just keep make it a positive because this I represents square root of -1 already. And then we're going to simplify the square root of 9, and which we have learned before. Square root of 9 is just equal to 3. So we get I times 3. But usually we like to put numbers in front of letters, so we write it as 3I. And so it means, which means 3 times I. It's a complex number, so it's a real number times imaginary unit. Now the next example we can do, what if it's not a perfect square? So we want to do square root of 10. And first of all, still we see with the radical sign it's a negative. We know it's not going to be a real number. It's going to be imaginary. So let's write down the imaginary unit I. And then once you write down the imaginary unit I, the minus sign is going to disappear. So you're just going to have square root of 10. And notice that square root of 10 cannot be simplified. And because 10 does not contain 2 copies of any number. So you can just leave it as this. And normally we like to put a number in front of the variable 3i, but if it's a radical, we would just keep it this way, because it's if you want to put this way, that also works. But make sure you don't put the I under this line, because this I is on the outside of the radical sign. And the next example, what if we have a fraction? Say, let's see, we have square root of -9/49. Again, if there's a minus sign under the square root, you have to change it to I, put an I there, and then to get rid of the minus sign. And now we're going to simplify the square root, and we can do square root of square root of 9 divided by square root of 49. So we can take the square root of the top and the bottom, which we have done this before in chapter 5. And we continue to simplify square root of 9, which gives us a 3, and the bottom square root of 49, which gives us a 7. Let's switch the number and the variable, so we can put your answer as 3/7 I. Another example, -3 times square root of -60. First of all, there's nothing we need to do about this -3 because it's not within the radical sign. But -6 is within the radical sign. And we see that to get rid of this minus, we're going to introduce the imaginary unit I. And we're going to get a square root of +60. And for square root of 60, we have to simplify that to the simplest form. So if you know 60 it can be factored as 2 times 30, and 30 is 2 times 15. 15 can be also factored as 3 times 5, but it doesn't really contain 2 copies of anything. You can just leave it as 15, but if you want to break it all the way down to 3 times 5, you can, but you still have to multiply that later. So we got multiplied, we got 2 copies of 2. Let's take them out. So that gives us negative 3 times 2. I'm going to put the numbers together. So this 2 comes from here, and square root of 4 is 2. And that I will keep it. So that would be this imaginary unit I. And then there's a square root of 15. We can go ahead and multiply negative 3 and a 2 to get negative 6. And I'm going to put a 15 and I. So I'm going to put negative 6 and that square root of 15. They're both real numbers together, and then put the imaginary unit after that. Make sure if you have a radical in your answer, it's always in the reduced form. Like square root of 15 is in the simplest form, and square root of 10 is in the simplest form. So why do we talk about imaginary numbers? In section 6.2, we're going to talk about quadratic equations. A quadratic equation is an equation that looks like this. You have a square in that equation. So first we're going to talk about, it looks like, for example, x squared equals, say, 36. That's called a quadratic equation because it has a square. And you may have, say, 3m squared plus 2m minus 1 equals 0. That's also a quadratic equation because the highest exponent is 2. We learned how to solve this kind of equations before. We learned to use factoring to solve these. But some of the polynomials or trinomials are not factorable. And so if they're not factorable, what should we do? So let's look at an example. And so here we are going to do, say, square root x squared is equal to, we can negative 9. Well, when we have, this is a simple type of quadratic equation because it doesn't have this term with the first power of x. So when you have a simple example like this, there's a quicker way to do this. We can take square root of x squared, because square root can get rid of the square. But when you take square root, make sure, so let me write down this question one more time and work on this. When we take square root of x squared, make sure you put a plus or minus on one side of the equation, because when we take square root, we always get 2 answers. Well, for example, one number squared will be 36. We know 6 squared is 36, but also 6 squared is 36, but also negative 6 squared is also equal to 36. So we should always get a one positive number and one negative number. So when we do this, you actually get x equals positive 6 or negative 6. And that 6 comes from square root of 36. So when you do this, you can take square root of both sides, and that gives us plus or minus 6. So similarly, when we can take square root of both sides, but we have to put a 1 plus and minus there. Square root of x squared will give us x, and plus or minus square root of 9, which we just did. Square root of negative 9 is equal to 3i. So you can use what we just talked about and to write down the answer, which is, so one number squared will be equal to negative 9. It's going to be 3i or negative 3i. Now the next example. So I guess this would be our example 1. This is our example 2. And now let's do example 3. What if it's not a perfect square like the one we can do negative 10? So we can do the same thing, take square root of both sides. And remember to put a plus or minus because we always have 2 answers. The left side gives us x. The right side, we know it's square root of 10i from previous example.